Hi everyone, in this video we are going to talk about the parallelogram properties and ways to prove that quadrilaterals are parallelograms like you saw in class this past week. So the first question we have here is ABCD a parallelogram? Why or why not? So if we take a look over here, we have that one pair of opposite sides is congruent. So that on its own is not enough to show that ABCD is a parallelogram because remember that one property of a parallelogram is that both pairs of opposite sides are congruent, not just one pair of opposite sides. So since I know that these two opposite sides are congruent, I can set them equal to each other. So I can find x, and then I can see if the other two sides are also congruent, which would make it a parallelogram. Adding 2 to both sides and subtracting 2x from both sides, I have x is equal to 12. Now, if I plug in, 12 times 2 is 24, minus 4 is 20. 12 plus 7 is 19. So no, ABCD is not a parallelogram because both pairs of opposite sides are not congruent. Remember, it's not just one pair of opposite sides, it's both pairs of opposite sides congruent to be a parallelogram. How about in this example? Can we prove PQSR is a parallelogram? The answer is not just with the information we have here. Just like in the last example, with the only one pair of opposite sides being congruent, here we only have one pair of opposite angles being congruent to each other. These two angles are both 100, but we don't know what the other pair of opposite angles are. We don't know if they are congruent to each other. We don't know that for sure. That's not told to us. If angle R and angle Q were also congruent, then we would know this is a parallelogram because then both pairs of opposite angles would be congruent. And in fact, if we did know this is a parallelogram, then we would also know that the consecutive angles are supplementary. So that's an interesting fact as well. But right now, with just the information that we have here, we don't have enough to conclude that we have a parallelogram. So here's a reminder of our properties of parallelograms, which are also our ways to prove that we have a parallelogram. So if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram because parallelograms have two pairs of parallel opposite sides. And I'll draw you a picture as well. Parallelogram has both pairs of opposite sides parallel. If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So let me draw you a picture. If both pairs of opposite sides are congruent, then we have a parallelogram. And we know that that's a property of parallelograms, that both pairs of opposite sides are congruent. Then we have if both pairs of opposite angles are congruent, our quadrilateral is a parallelogram. And next, if the diagonals bisect each other, then the quadrilateral is a parallelogram. So if you know that you have a parallelogram, you know that these 5 things are true. And if you want to prove that you have a parallelogram, all you have to do is prove just one of these properties. You don't have to prove them all. That would be a whole lot. You just need to prove one to know for sure that you are dealing with a parallelogram. Let's take a look at this example over here. So we are given that AB is congruent to DC, and we are given that AB is also parallel to DC. And we want to prove that ABCD is a parallelogram. So remember, our given information is there for a reason. We have parallel sides, so I'm going to highlight my parallel lines and the transversal that intersects them. And I can see my congruent alternate interior angles that are formed in the corners of the letter Z inside the parallel lines on different sides of the transversal. And I also see the shared side of triangle ADB and triangle BCD. BD is congruent to itself by the reflexive property. So now I know that these two triangles making up this quadrilateral, that these two triangles ADB and CDB are congruent, and they are congruent by side, angle, side, side, angle, side. And once we know that the two triangles are congruent, well, we can say side AD, which is a side of this triangle, is congruent to side BC, which is a side of the bottom triangle, due to CPCTC. If we already proved these two triangles congruent, we know that their corresponding sides are also congruent from CPCTC. I'm going to take a second and write up this proof because now we know that ABCD is a parallelogram. We have shown that both pairs of opposite sides are congruent, and that's one of our methods of proving that we have a parallelogram. I'm going to take a second and write up the proof. Feel free to pause the video at this point if you'd like to try to write it up yourself. So here we have the proof, and notice that at the end we ultimately prove that ABCD is a parallelogram because if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So what we have shown here is that if we start with the information that just one pair of sides, here it was AB and DC, are both congruent and parallel, that's enough to prove that we have a parallelogram. So let's go back to our list of methods from before, and we can add this one over here. Let me put it over here. That would really be what would that be? Number 6. How many do I have before? The numbers are all jumbled up. 1, 2, 3, 4, number 5. If one pair of opposite sides, are both congruent and parallel, the quadrilateral is a parallelogram. And I can draw a picture of that right over here as well. If one pair of opposite sides is both congruent and parallel, we know that we have a parallelogram. Okay, moving along. So let's take a look at the next proof example. So we know that angle 1 is congruent to angle 2, and we know that WZ is parallel to XY. We need to prove that XYZW is a parallelogram. Take a second to pause the video if you need some time to think about it. But I want to pay special attention to what we already have and what we can get. So we already know that one pair of opposite sides here, WZ and XY, is parallel. So it would be really great for us, since we're trying to show that we have a parallelogram, if we could show that the other pair of opposite sides are parallel, or if we could show that the same pair of opposite sides is congruent. Because remember, congruent and parallel does make a parallelogram. I don't see any other information about WZ and XY to conclude that they're congruent, so that might be a little bit tricky. I could possibly prove that with CPCTC if I were to prove the triangle's congruent. But there's an easier way. Since we have information about angle 1 and angle 2, let's think about what kind of angles angle 1 and angle 2 are. Notice how they are formed by lines W, X, and ZY, and the transversal that intersects them. And notice how we have our letter Z inside the lines on different sides of the transversal. Those are alternate interior angles. And guess what? If alternate interior angles are congruent like they are here, that means that the lines forming them are parallel. And guess what? If both pairs of opposite sides are parallel, that means the quadrilateral XYZW is a parallelogram. So we actually are done with our proof. I'm going to take a second and write it up. pause the video so you can write it up as well and then check your answer. So this was actually only a 3-step proof. So take a second and pause the video so that you can read through it and see if you had the same thing. Here's our next example. So in triangle GKL, LM is a median. So remember, a median of a triangle connects midpoint to opposite vertex. So if LM is a median of triangle GKL, that means M is the midpoint of the side since the median connects vertex to midpoint. And midpoints cut sides of the triangles into 2 congruent segments. That's our first given and the conclusion we can draw from it. Then we're told that LM is congruent to MJ. We need to prove that JGKL, the whole big quadrilateral, is a parallelogram. We actually already have enough information to say that it is. Can you find which property of parallelograms applies that we have proved here? We have proved that the diagonals bisect each other, which makes a quadrilateral a parallelogram. Take a second and write up the proof. Pause the video and remember that everything that is marked in your diagram needs to go into your proof. Here we have the proof. Take a second, pause the video, read through it, and make sure it matches up to what you wrote on your own. Notice how at the end, we do prove that JGKL is a parallelogram because if the diagonals bisect each other, the quadrilateral is a parallelogram. Take a second and try to write down why each quadrilateral is a parallelogram. Pause the video so you can do that. In part A, the quadrilateral is a parallelogram because both pairs of opposite angles are congruent. In B, the quadrilateral is a parallelogram because one pair of opposite sides is both congruent and parallel. In C, the quadrilateral is a parallelogram because both pairs of opposite sides are congruent. And in part D, the quadrilateral is a parallelogram because the diagonals bisect each other. Here we have some numerical examples. So let's assume that in each of these examples, the given is that we have a parallelogram. So that way we can use all of the properties that we know about parallelograms. So in the first example, since quadrilateral is a parallelogram, I know that the opposite sides are congruent to each other. So if RS is 6, UT also has to be 6. If RU is 9, SU also has to be 9. Looking at the angles, I know that opposite angles are congruent. So if this angle is 80, the one across from it also needs to be 80 degrees. And I also know that in a parallelogram, any 2 consecutive angles, so any 2 angles right next to each other, are supplementary. So this angle and this angle, they're one right after each other. They're consecutive angles, so they are supplementary. So 180 minus 80 is 100 degrees. And then because opposite angles are congruent in a parallelogram, angle T should also be 100 degrees. Moving on to the second example, we know that in a parallelogram, the diagonals bisect each other. So I know that this diagonal is being cut in half equally, and this diagonal is being cut into 2 congruent parts. So I can set up an equation to find x, and then an equation to find y. So to find x, I know that 18 is equal to 2x plus 8. Subtracting 8 on both sides, we have 10 is equal to 2x, and that gives us x is equal to 5. To find y, we can set up the equation for my y minus 2 is equal to 22. Adding 2 to both sides, we have 4y is equal to 24. And then dividing both sides by 4, we have y is equal to 6. In the last example, we know that in a parallelogram, opposite sides are congruent. So this side's congruent to this side, and this side's congruent to this side. So I know that 8 is equal to 4x, and that means that x is equal to 2. 8 divided by 4 is 2. I also know that 3y plus 4 is equal to 13. So that tells me 3y is equal to 13 minus 4 is 9. And that means y is equal to 3. The last thing we're going to talk about is how to prove a quadrilateral is a parallelogram using coordinate geometry. So you have a couple of different options because you have a couple of different ways of proving that you have a parallelogram. So let's go back for a second to our properties, our ways of proving that we have a parallelogram. So we can prove that both pairs of opposite sides are parallel using slope formula in coordinate geometry. Remember, if we have the same slopes, that means lines are parallel. This would involve 4 slope formulas because you would need one for each side to show that both pairs of opposite sides are parallel. You can show that both pairs of opposite sides are congruent. That would be using the distance formula. And that would be 4 distance formulas, one for each of the sides to show that this pair of opposite sides is congruent and this pair of opposite sides is congruent. Angles we can't show in coordinate geometry unless we're talking about right angles, but parallelograms don't usually have right angles or don't always have to have right angles. So we don't really have a formula that could be used to find angles. So that one's not really going to apply to coordinate geometry. If diagonals bisect each other, the quadrilateral is a parallelogram. If the diagonals bisect each other, they should have the same midpoint. So this would involve finding the midpoint using midpoint formula of each of the diagonals and showing that they are the same. So that is 2 midpoint formulas. And finally, we can show that one pair of opposite sides is both congruent and parallel. That would be slope formula 2 times to show that the sides are parallel, and distance formula 2 times to show that that same pair of opposite sides is also congruent. So you can pick whichever method that you want to use, whichever formula you like best, as long as you are proving one of the properties of parallelograms. So let's go back, and I'm just going to pick one that I want to use. So let me just draw myself. I don't have a coordinate grid here, but I can draw myself an estimate grid just because I want to see where the points are located. So P is 1, 1, so that would be somewhere here. Q is 2, 4, so that would be to the right and up from point P. Then we have R is 5, 6, somewhere over here. And then S would be 4, so farther down than Q, but 3, lower down than Q. So that is S. So let me connect together. Not the best grade, but at least we can see where the points are located. Because the property that I like to use is I like to show that the diagonals bisect each other because I like to use midpoint formula the best. So all I'm going to do is use midpoint formula for diagonal QS and midpoint formula for diagonal PR and show that the midpoints are the same. So I'm using midpoint formula. So midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. And let me show my work down here because I don't have enough space. So the midpoint of QS would be 2 plus 4 over 2, 4 plus 3 over 2. That's 6 over 2, which is just 3. 7 over 2. That doesn't simplify any further to a nice number. And then we have the midpoint of PR. That would be 1 plus 5 over 2. And 1 plus 6 over 2. 1 plus 5 is 6. 6 divided by 2 is 3. 1 plus 6 is 7. 7 over 2 doesn't simplify any further to any nice number. So notice here The midpoints of the diagonals are the same. So that means the diagonals bisect each other, making this a parallelogram. So then, as usual with any coordinate geometry proof, I'm going to end with a concluding statement summarizing what my calculation showed and what I proved with my calculations. So I'm going to write over here, since the midpoints of the diagonals are the same, the diagonals bisect each other, making PQRS a parallelogram.